All right, hello again. We're going to do chapter 10.1, solving equations, and the main point of this section is addition principle. So before we tackle solving equations, we're going to go over a little bit of vocab. First thing is, what is an equation? An equation is a mathematical sentence that states two expressions are equivalent. So one of the more basic things we could write for an example of this is, let's say 1 plus 1. This is an expression in which we have constants and an operation going on, is equal to 2, which is also an expression because a constant by itself is an expression. And this is a true statement. It's a statement that says 1 plus 1 equals 2, which we all can agree about. So this is an example of an equation in which that equal sign is there. And there's two different expressions that mean the same thing. Now what we're going to do is we're going to have solutions of equations in which we want to solve equations. And a solution is any replacement for a variable that makes an equation true. So real quickly, let's give ourselves an expression in which we have, instead of constants only, maybe some variables thrown into the mix. We have x plus 1 equals 2. Now a solution to this equation is going to say x equals a value that makes the statement true. And if we kind of sneak peek before, 1 plus 1 equals 2. So the only solution for x is for x to equal 1. So x equals 1 is a solution. We can replace 1 in for x and we'll make this statement true. So let's get a little bit of practice with that. Now we are asked to determine whether x equals 6 is a solution of x plus 7 equals 13. So pretty much what we're going to do is we're forming a check of sorts. And we're going to take our equation, x plus 7 equals 13, and instead of x, we are going to fill in what x equals. X is really 6. And now it's up to us to determine if 6 plus 7 equals 13. Notice I wrote a question mark. I'm not sure if they're equivalent. But 6 plus 7 is 13, and 13 does equal 13, so we're good. So we say yes. X equals 6 is a solution. We could simply say yes. I just was being more detailed on what our solution is. So let's go ahead and tackle the next one. It says determine whether x equals 3 is a solution of 7x plus 7 equals 30. Now we're getting a little bit more challenging. So let's be careful. We have 7x plus 7 equals 30. Now instead of x, we want to plug in 3. But you want to be careful. What's going on between the 7 and the x? Multiplication. So we are going to fill in that this is 7 times whatever our x is, and instead we're plugging in 3. And we're not sure if this is equal. So let's go ahead and simplify. And we're going to simplify one side as much as possible, following order of operations. 7 times 3 is 21. 21 plus 7 is 28. Does 28 equal 30? And we'd say no. So the answer to this question is no. X equals 3 is not a solution. So now that we know about how we find solutions when they give it to us, they're saying determine if it's a solution, we're going to now want to start from saying, okay, we gave you an equation and we want you to find the solution that works, and there's no extra info given to you. Now how we're going to do that is by using a thing called the addition principle. We don't necessarily always are adding with the addition principle. Sometimes we're subtracting, but it's like the grand scheme of things. This is the general idea. So for any real numbers, a, b, and c, and we know what real numbers are, so we're safe. If we start with something like this, if a equals b, then this is equivalent to a plus c equals b plus c. So let's soak on that for a bit. Let's say we start with a true statement. Let's say 0 equals 0. Now, my a and b are kind of dumb. They're the same thing already, but I'm just describing them as constants. These can be expressions. This could be x plus 200 equals 5 billion. But I want to describe it in an easy sense so we can kind of check this idea. So, if I want to add c is a real number, to one side of the equation. Let's say we add 5 to one side. Then I better add 5 to the other side, because what I do to one side, I must do the same to the other. Now let's see. What's 0 plus 5? 5. What's 0 plus 5? 5. Does 5 equal 5? Yes, it's still the same statement. We still have a true statement. It looks a little bit different, but it still means the same thing. So addition principle, kind of the fancy talk for saying what we do to one side, we must do the same. And it's the same that we have to do to the other. Let's go ahead and apply this now. So let's solve for the variable. And let's say the first one we're going to have here is x minus 3 equals 8. So we want to solve for x. Whenever we write a solution, we always have x equals some value. That's our solution. So we need x by itself. Currently there's a minus 3. We don't like that, so we want to undo it. And how can I undo minus 3? Well, I'll do the opposite. Instead of subtracting 3, I want to add 3. Because negative 3 plus 3 is 0. 0 plus anything is the same thing, so I'd be left with x on one side of the equation. But if I add 3 on one side of the equation, and here's our two sides of the equation, right? I must do the same thing to the other. So what's 8 plus 3? And it's 11. So let's see. We're saying x equals 11, and we can always check ourselves. And I don't know, we're going to say check. So we have x is 11 minus 3. Does that equal 8? 11 minus 3 is 8. 8 does equal 8, so we're good. So x equals 11 is our solution. Let's go ahead and tackle another one. So this one's going to be a little bit more challenging. Let's say we have negative 8 plus x equals negative 15. So I worded this a little bit differently. We have negative 8 plus x equals negative 15. We still want to get x by itself. And if you remember, whatever's in front of the term for an expression always goes with it. So the plus sign's with the x. But in front of the 8 is the minus sign. So we want to undo that minus because we want to move the 8 to the other side so we get x by itself. So what we're going to do is the opposite of subtracting, which is adding. And what we do to one side of the equation, so here's our two sides. We have the side with the x, the side we want to mess with, and we'll move it over to the other side. So negative 8 plus 8 is 0. They cancel each other out, and we're left with x equals, and now we have negative 15 plus 8, which gives us negative 7. And there is our solution. And we could plug it in. Negative 8 plus negative 7 is in fact negative 15. So it's always nice to double check yourself. Let's go ahead and try a little bit funkier of one. Maybe we'll throw in some decimals into the mix. Let's say we have 10.8 equals, oh, and I don't know, let's be crazy. Let's say z plus 4.9. Now, to remind you, let me show you the directions. It said solve for the variable. And we're not always going to have x. Usually we solve for x because that's the more common variable we like to use, but sometimes we'll have a z, maybe we'll have a y, a q, who knows. So whatever the variable is, that's the side of the equation you want to mess with. So here's our equation. We have our two sides. We have currently z plus 4.9. So this is the side we want to mess with because there is our variable. We have a plus 4.9. We want to do the opposite. So the opposite of adding is subtracting. And what we do to one side of the equation, we must do the same to the other. So now we're left with z equals, And we got to subtract here, so we're going to have to go ahead and borrow. We have 18 minus 9 is 9. 9 minus 4 is 5. And since we're subtracting decimals, we have to make sure the decimal points line up. And there's our answer. Z equals 5.9. And you can write it the other way. I don't care which way you go. They both mean exactly the same. You will see more often this way that I'm trying to star. We like to see the variable first. That's more often the way we like to see it. But it doesn't make a difference. Both are equivalent. Let's go ahead and do another one. It's going to be a little bit more tricky just for the sake of practice. We're going to have some, let's do mixed numerals. We have 6 2/3 equals 4 1/2 plus x. Now remember, the sign in front of the term is what's going with it. So in front of this 6 2/3 is positive, right? Oops, let's write it, positive. In front of that 4 1/2, it's positive. In front of the x, we actually already written, it's positive. So let's see. We want to mess with the side where the variable is. So the x is on the right-hand side here. That's the side we're going to mess with. We have a 4 1/2 plus x. We want to undo it. The sign in front determines what you want to undo. It's a positive, so just to undo it, we subtract. And what we do to one side of the equation, we must do the same to the other. Now we just have a little bit more work here because we have 6 2/3 minus 4 1/2. So let me go ahead, rewrite this, and do this off to the side. When we're subtracting mixed numerals, you subtract the fraction part first. In order to subtract fractions, or add fractions for that matter, we need a common denominator. So between the two, 6 is the common denominator. So let's go ahead and make both have 6 as the denominator. So we have 6 and 4, 6, minus 4 and 3, 6. We'll subtract. 4, 6 minus 3, 6 is 1, 6. 6 minus 4 is 2. Now, don't just write this as your answer. You have gotten x by itself. You're solving for this equation, so you need to write a solution. And a solution, you have to describe what the variable equals. So even if we were to go back to the way beginning, we say determine whether x equals 6 is a solution. Notice how the solution is written, x equals. It is very important that we do that here. And that's our answer. So they could give us any sort of fractions, decimals, crazy things, and if we do what we do to one side, we do to the other, we're safe. And that is how we solve equations.